Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is problem solving on critical regions in hypothesis. First, just we will revise the critical region. Actually, in hypothesis testing, the critical region generally represented by the set of the values and where we will reject our null hypothesis. So that is, we will say that region of the rejection. So generally it takes the different boundaries values for different level of the significance, and here the graphs will show the some critical regions in the hypothesis testing. There is a level of significance. There are level of significance will be 3, 1%, 5% and the 10%. If you are using the two-tailed test, at that time you are at the 1%, your level of significance will be that minus 2.5 to 2.58, then minus 1.962 to 196, minus 0.645 to 0.645. Then after that right tail test, then again 2.33, 1.64 and 1.28. Then after that, if you are using the left tail test, then minus 2.33, minus 1.64 and minus 1.2. That means these values are changing according to the level of significance. And if two-tail test, here you can check that these things are, that means this region is the rejected region, this side the rejected region, and this middle region is the accepted region. In right tail, this region is rejected, and if left tail, this region is rejected and remaining portion is the accepted region. So numbers will change for your level of significance values, but the representations and the idea of two-tailed, left tail, then right tail test will be the same. So here same values we have explained according to the level of significance 1%, 5% and the 10%. Now two-tailed test, right tail test and left tail test. According to that and according to your level of significance, your values will be changed. Now we will see question first. The telecom service provider claims that individual customers pay on an average 40 rupees per month with standard deviation 25 rupees. A random sample of 50 customers bills during a given month is taken with the mean of 250 and a standard deviation of 15. Now what to say with respect to the claim made by the service provider? Now solution is that first we will note down whatever we have given. Here null hypothesis, that means H0 has given, that is 400. H1 alternate hypothesis is not equal to 400. That means your value will be greater than 400 or less than 400. So it will be validated. It will be come under the two-tailed test. So sigma value is 25. That means we can say that the population standard deviation. Then level of significance. Here we have taken the 5% because in question they didn't mention any level of significance, so they didn't mention, that's why we have taken 5%, and n, that is the sample size, is a 50. Here x bar value is a 250, that is sample mean, and s is a 15, sample standard deviation. Now here your n value is greater than 30. That means we can go with the z test. Now first step is that you have to calculate the z test by using the formula, and the z-test formula is that x bar minus mu divided by sigma divided by square root of the n, and by solving this your z value is minus 42 minus 42 minus 42.42. So step 2, now you got the value of z. In step 2, now z critical value from the z table. for the level of significance 500 we have to find out. So critical values are the minus 1.96 and plus 1.96. And here we have to accept the claim. We have calculated z between the minus 1.96 less than z less than 1.96. But we have calculated the z of z value minus 42.42. That means less than minus 1.96. So by using, when we have observed these values, we have to reject our null hypothesis. So these things we will reject and these things. So your two-tailed test alpha is equal to 5%. Here we have to reject our null hypothesis. And z value is less than the critical value, so we have rejected our null hypothesis. Now second question is that from the data available, it is observed that 400 out of the 850 customers purchase the groceries online. Now can we say that the most of the customers are moving towards online shopping even for the groceries? Now solution is that 400 out of 850, which indicates that this is the proportion problem. And proportion, that means we can say p, small p we are representing by the small p. 400 divided by 850. By solving this, you will get the 0.47. Now after that, H0, null hypothesis, which is P, capital P, greater than 0.5. And here, we will claim that most of the customers are moving towards the online shopping, even for groceries, which means at least 50% should do online shopping. Now H1, that is alternate hypothesis, is less than or equal to 0.5, which is left-tailed, and n is equal to n50. So here, level of significance is equal to 5% and n greater than or equal to 30. So we will go with the z test. Again we will find out the z value using the z test formula, which is z is equal to small p minus capital P divided by square root of p into q divided by n. So by keeping these values, here small p value is 0.47, capital P value is, small p value is 0.47, capital P value is 0.50, then q value is 0.5. And after solving these things, you will get the z value is equal to 1.47. Then second step is that you have to use here z table for the 5% level of significance. And when you will find out the value for this, you will get the value z is equal to minus 1.645, which is left-tailed problem. So z-tailed here 1.74 is greater than minus 1.645. So here we have concluded that we have to accept null hypothesis. That means given data we can validate it significantly, and most of the customers are moving towards the online shopping even for groceries. So here only minus 1.645, this portion we will reject and remaining portion we will accept. Now question 3 is that it is found that 250 errors in the randomly selected 1000 lines of the code from team A and 300 errors in 800 lines of the code from team B. Now can we assume that team B's performance is superior to that of the A? Here there are two samples. One is the team A and another one is the team B. and each of the teams have some of the proportions, which is given in terms of the line of the error out of the total line of the code. Line of the error divided by total line of code. Hence, this problem we will solve using two proportion z-test. One or two proportion type problem we will use the z-test. That means in case of multi-proportion we can use x square, that is chi-square test. Team A, that means we will say take that sample A, proportion P is small p, that is 250 divided by 1000, you will get the 0.25 and NA value is 1000. Team B, proportion PB, 300 divided by 800, so you will get 0.375 and NB value is 800. Now we have to take the level of significance 5%. Now Team B's performance is superior than Team A. We have to find out, we have to check. Here null hypothesis is showing that overall mean error of Team B, mu B less than mu A, overall mean error of Team A with respect to the population. And alternate hypothesis, mu B is greater than or equal to mu A, which is showing the right tail test. First, we will calculate the z value from two proportion z test formula. We have the formula for z test, PA minus PB divided by P cap or P hat into 1 minus P hat into 1 by NA plus 1 by NB. Now P hat, we have to find out the P hat value. 1000 into 0.25 plus 100 into 0.375 divided by 1000 plus 100, 800 is equal to 0.305. After that Z, that means we got the Z value is equal to minus 0.125 divided by 0.212 into 0.0135. Z value we got minus 436.76. Now step 2 is that you have to use here Z table. For the level of significance 5%, you will get the Z value 1.645. Now you have calculated Z minus 436.75 is less than 1.645. So here null hypothesis, we have to reject the null hypothesis, which means from the data given proven significantly that Team B's performance is better than Team A's performance. And here Z value fall inside the acceptance region, hence we have to accept the null hypothesis. Then question 4 is that following is the record of number of accidents took place during the various days of the week. 120 Monday, 120 Tuesday, 140 Wednesday, 200 Thursday, 90 Friday, 140 Saturday, 120 and Sunday, 180. Now accidents took place in various days of the given week. Now can we conclude that accidents are independent of the day of the week? Let's check. First, whatever we have given, just we will write down. H0 is accidents are independent of the day and H1 is the not independent. Here each day will represent a sample and observe the accident data is proportion. Hence this problem can be categorized as a multi-proportion problem. This is a multi-proportion problem and we will solve by using the X square, that is chi-square test. So below table is showing some observed values of the accident in first column, and now we want to validate that accidents are independent of the day of the week. For the average accident on each day should be different. Now hence we need to calculate average accident on each day and this will be called as expected value. in X square test, that is chi-square test. Level of significance, we will take the 5%. Now step 1, calculate the expected value and X square values using the X square formula. So this is your table, observed values, these are expected values, and this is your chi-square values. After solving this, you got the total 990 and here total of X square 139.997. Now step 2 is that X square table for level of significance is 5% and get X square values from the table. Now from the table we got X square, that is critical value at 5% will be 3.841. Now step 3, compare both X square values. Here chi-square value is 18.99 which is larger than the critical value 3.84. 1899 is greater than 3.84. So we have concluded that we have to reject our null hypothesis and we have to accept here alternate hypothesis, which is showing we can conclude significantly accidents are not independent of the day of the week. So we will reject this portion 3.841, that is chi-square value fall inside the rejection region. Hence, we will reject the null hypothesis. Now question 5 is that analyze the below data and tell whether you can conclude that smoking causes cancer or not. Category are smokers, non-smokers and total. Diagnosed as a cancer, without cancer and a total. Now chi-square test check the independence of the two categorical data. Here in this question, we need to test whether smoking and cancer are independent or dependent to each other. Hence we will perform the chi-square test. Now let's check. First, H0, which is null hypothesis, is cancer is dependent on the smoking, and H1, alternate hypothesis, cancer is not dependent on smoking. Now step 2 is that calculate the expected value for each cell of the table. Here whatever you have given you for this value, you have to find out the expected value. Expected value is specifying what the values of the each cell of the table would be if there is no association between the two variables. And the formula for computing the expected values requires the sample size, row tables and the column tables. Now expected value is equal to row total into the column total divided by the table total. Now create another table with the observed and the expected values. Here again diagnosed as cancer, observed and expected values. Observed, expected values. Every time for smokers and non-smokers, we will find out the observed and expected values. Now after that, we will calculate the chi-square value. Chi-square value is equal to summation of observed minus expected values whole square divided by expected value. When you will keep all these values, you will get the 58.2. Now step 4 is that here we have to decide if X square is statistically significant. Final step of the chi-square test is significance is to determine if the value of chi-square test statistic is large enough to reject the null hypothesis. Now we will check the X square table for the critical value. Level of significance 5%. So from table we got X square value, that is critical value 3.841. So chi-square test of the 58.2 is much larger than critical value, which is 3.84. So null hypothesis we will reject. That means the cancer is not dependent on the smoking. So here one tail test, this thing will be rejected because the chi-square value fall inside the rejection region. Hence we will reject the null hypothesis. Now next question is that it is claimed that mean of the population is 67 at 5% level of the significance. Mean obtained from the random sample size 100 is a 64 with standard deviation 3. Validate the claim. Now solution is that H0 null hypothesis value is 67 and H1 not equal to 67, that is 67 mu value, your null hypothesis is greater than 67 or less than 67. Level of significance we will consider here 5%. Null hypothesis, not null hypothesis, sample size n is 100. X bar is equal to 64, S is equal to 3 and n is greater than 30. So we will consider here again Z test. First you have to calculate the Z value by using the formula X bar minus mu divided by sigma divided by square root of n. So Z value we have got minus 10. Then step 2, we have to calculate the critical value for level of significance 5% by using the Z table. Now you will get the critical values minus 1.96 and plus 1.96. That is showing the two-tailed test. Now step 3 is that you have to calculate the Z value between Z critical value, then accept the null hypothesis. If Z calculated is outside Z critical, then reject the null hypothesis. So here Z calculated value is equal to minus 10, which is lesser than the left side of the Z critical value, minus 1.96. So hence we will reject the null hypothesis. Now conclusion that we have proved that our population mean is not equal to 67. Here this is your two-tailed test, so we will reject these values, these reasons, minus 1.96 and 1.96 and minus 10. This Z value is fall under the inside critical region, so we will reject the null hypothesis. Now question 7 is that there is assumption that there is no significant difference between boys and girls with respect to intelligence. Tests are conducted on two groups and the following are the observations. Mean standard deviation and the size, girls and boys. Validate the claim 5% level of the significance. Now solution is that first H0 is that no difference between boys and girls in terms of the intelligence. That means both are the equal. And alternate hypothesis, both girls and boys are different in terms of the intelligence. So mu2 is not equal to mu2. So these are two-tailed tests. So X bar value is a 75 and X2 bar is a 73. 75 is showing the boys sample mean and 73 is showing the girls sample mean. Level of significance is 5%. So there are two sample mean for boys and the girls. Hence we will solve this two mean problem. Both sample sizes, N1 is a 60 and N2 is a 100. And here these are greater than 30, so we will use here again Z test. Z value we will find out by using the formula. After keeping the all values in the formula, you will get the Z value 1.39. Then step 2 is that you have to calculate the critical value for level of significance 5%. And after that you will get the values minus 1.96 and 1.96. Then step 3, check if calculated Z value is between the Z critical value, then we have to accept the null hypothesis. If Z calculated is outside Z critical value, then we have to reject the null hypothesis. Here Z calculated value is between the Z critical value. So that critical value is minus 1.96 less than 1.39 less than 1.96. So here we will accept the null hypothesis. That means it's proved that there is no significant difference between the intelligence of boys and the girls. So here we will reject these things. This is two-tailed test and Z value fall inside the acceptance region, hence accept the null hypothesis. So these are the references. This is all about the problem solving on the critical regions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.